Siang 4401 Data Communications and Computer Networking Lecture 1, Introduction to Communications. Course Outline 1. Concept of Communication, Communication Model 2. Protocols and Architectures, Protocol Characteristics, Implementation of Protocols, OSI ISO 7 Layer, TCP/IP3. Data encoding and transmission, digital and analog signals, transmission media, encoding techniques, transmission impairments. 4. DLC and multiplexing, error detection and control, flow control, multiplexing. 5. LAN technologies, Aloha, Ethernet, Ethernet standards, token ring. 6. LAN and its components, LAN topology, repeaters / hubs, bridges / switches, routers. 7. Internetworking, internetworking concepts, intranet, extranet, internet, internetworking with TCP/IP, IP addressing, subnetting, masking, network applications, web, mail, DNS, DHCP. 8. Switching and routing, circuit switching application, packet switching, virtual packet switching, datagram packet switching application. 9. Routing in switched networks, introduction to routing, graph theory. Dijkstra algorithm, Bellman-Ford algorithm. 10. Routing protocols, distance vector, link state. 11. WAN technologies, ISDN, X.25, frame relay, ATM. Data communications. The term telecommunication means communication at a distance. The word data refers to information presented in whatever form is agreed upon by the parties creating and using the data. Data communications are the exchange of data between two devices via some form of transmission medium such as a wire, cable. Network. A network is a set of devices, often referred to as nodes, connected by communication links. A node can be a computer, printer, or any other device capable of sending and/or receiving data generated by other nodes on the network. The most common resource shared today is connection to the Internet. Components. A data communication system has 5 components. Figure 5 components. Soft data communication. 1. Message. The message is the information, data, communicated. Such as text, numbers, pictures, audio and video. 2. Sender. The sender is the device that sends the data message. It can be computer, telephone, handset, video camera and so on. 3. Receiver. The receiver is the device that receives the message. It can be computer, telephone, handset, television and so on. 4. Transmission medium. The transmission medium is the physical path by which a message travels from sender to receiver. Coaxial cable, fiber opticable and radio waves. 5. Protocol. A protocol is a doferless govern data communications. It represents an agreement between communicating devices. Criteria of effectiveness of data communication delivery. Data must arrive at the correct destination. Data only arrive at the right destination. Accuracy. Data must be correct without any error. Timeliness. Data must be delivered in time. Linear jitter. Variation in the data arrival time at the detonation. Different applications have different requirements on these criteria. Data communication mode / data flow. The 3 data communication modes are simplex, half-duplex, or full duplex as shown in figure. Data flow, simplex, half-duplex, and full duplex. 1. Simplex. In simplex mode, the communication is unidirectional, as on a one-way street. Only one of the 2 devices on a link can transmit, the other can only receive. Keyboards and traditional monitors are examples of simplex devices. 2. Half-duplex. In half-duplex mode, each station can both transmit and receive, but not at the same time. Walkie-talkies and CB, Citizens Band, radios are both half-duplex systems. Pros. Entire bandwidth can be used for transmission. Cons. Not suitable for high interactive application. 3. Full duplex. In full duplex both stations can transmit and receive simultaneously. Example: telephone network. The capacity of the channel, however, must be divided between the 2 directions. Data flow, cont. A communications model source generates data to be transmitted. Transmitter converts data into transmittable signals. Transmission system, carries data. Receiver, converts received signal into data. Destination, takes incoming data. A simplified communications model. Simplified data communications model. Networking point-to-point communication not usually practical, devices are too far apart, large set of devices would need impractical number of connections. Solution is a communications network. Networking, computers communicate with each other via networks. Computer network, a communication system for connecting computers using a single transmission technology. Simplified network model. Network topology. The pattern of interconnection of nodes in a network is called the topology. There are a number of factors to consider in making this choice, the most important of which are set out below. 1. Cost. For a network to be cost-effective, one would try to minimize installation cost. 2. Flexibility, because the arrangement of furniture, internal walls etc. in offices is often subject to change, the topology should allow for easy reconfiguration of the network. This involves moving existing nodes and adding new ones. 3. Reliability. Failure in a network can take two forms. Firstly, an individual node can malfunction. This is not nearly as serious as the second type, default, where the network itself fails to operate. Simple physical topologies. Physical topology, physical layout of nodes on a network. 4 fundamental shapes: bus, ring, star, mesh may create hybrid topologies. Topology integral to type of network, cabling infrastructure, and transmission media used. Why we need a topology. Choosing one topology over another can impact type of equipment the network needs, capabilities of the equipment, network's growth, way a network is managed. Bus Fig 06-01. Simple physical topologies. A bus topology, one of most simple net topology. All nodes are connected into a single cable called a backbone. Every node sends and receives data through this bus/backbone. Fig 05-01. Bus, continued. Devices share responsibility for getting data from one point to another. Terminators stop signals after reaching end of wire, prevent signal bounce. Inexpensive, not very scalable. Difficult to troubleshoot, not fault tolerant. Bus advantages. Disadvantage: works well for small networks, easy to install and add a new node, relatively inexpensive to implement, and requires smaller cable length than star topology. The main cable requires terminators at both ends. As the hashtag of devices increases, it drops down the efficiency of bus net. Not appropriate for networks with heavy amount of traffic. Security is low. B/C. All the nodes receive the signals from the source. Network disruption: when computers are added or removed, a break-in the cable will prevent all systems from accessing the network. Ring Fig 06-02. Simple physical topologies. Ring topology: each node is connected to the two nearest nodes, so the entire network forms a circle. One method for passing data on ring networks is token passing. Tokens used to transmit data, and nodes must wait for token to send data. Travels around a network. Data pass through all nodes until it reaches to destination. Time to send data is known. No data collisions. Traffic flows in one direction. Slow performance: one workstation goes down, whole network goes down. Network is highly dependent. Fig 05-03. Ring advantages. Disadvantage: no central device for controlling the network, provides equal access to devices and not a single node. Use all the BW cable faults are easily located, making troubleshooting easier. Ring networks are moderately easy to install. Transmission signals goes in sequential order, which create delays. Expansion to the network can cause network disruption. A single break in the cable can disrupt the entire network. Star Fig 06-03. Simple physical topologies. Star topology: every node on the network is connected through a central device called hub or switch. Communication takes place via hub/switch. Fig 05-04. Star, continued. Any single cable connects only two devices. Cabling problems affect two nodes at most. Requires more cabling than ring or bus networks. More fault tolerant, easily moved, isolated, or interconnected with other networks. Scalable. Star advantages. Disadvantage: good option for modern networks, easy to install and wiring arrangement. Transmission delays don't increase if a new node is added. Easy to manage. Addition and removal of parts is easy in star topology. It is easy to detect faults. Most popular topology in use. wide variety of equipment available. Hub is a single point of failure, requires more cable than the bus. Mesh. Simple physical topologies. Mesh topology, each computer connects to every other. High level of redundancy provides one-to-one connection among all computers. Rarely used, wiring is very complicated, cabling cost is high, troubleshooting a failed cable is tricky. A variation hybrid mesh create point-to-point connection between specific network devices, often seen in one implementation. Mesh advantages. Disadvantage: allows to send data from D/T devices simultaneously. There is the advantage of privacy or security. The network can be expanded without disruption to current uses. Point-to-point links make fault identification and fault isolation easier. Requires more cable than the other LAN topologies. Complicated implementation, installation and reconnection are difficult. Expensive. Overall cost is high as compared to other topologies. Hybrid physical topologies. One example of hybrid topology is tree topology. Tree topology is a combination of bus and star topology. It consists of groups of star-configured workstations connected to a linear bus backbone cable. If the backbone line breaks, the entire segment goes down. An example of this network could be cable TV technology. Choosing a topology. Bus network is small. Network will not be frequently reconfigured. Least expensive solution is required. Network is not expected to grow much. Star. It must be easy to add/remove PCs. It must be easy to troubleshoot. Network is large. Network is expected to grow in the future. Ring. Network must operate reasonably under heavy load. Higher speed network is required. Network will not be frequently reconfigured. Thank you.